Everyone, welcome back to my channel. In this video we are going to solve the popular grid problem that often shows up in the interview, especially for the companies like Meta and big tech firms. In this problem, the battleship in a board, also known as lead code number 419, I will explain the problem statement and then we'll walk through the Java solution code step by step, including how we read inputs and how the logic works internally. Let's get started. In this problem statement, as we can see, we have a 2D representation, the grid, and which has cell value as x and the empty cell or dot. So your task is to count how many distinct battleships are on the board. Okay, and the rule is valid battleships. The valid battleship rule says that it can be only placed horizontally or vertically. Each battleship is made of one or more consecutive X cells in the straight line. No two battleships are adjacent, that means they do not touch each other either horizontally or vertically. And you are not allowed to modify the original board, and you must solve it with big O of one extra space and O of m into n time complexity, where m is the number of rows and n is the number of columns. Okay, so here is the solution. Look at high level idea what we are doing. So instead of doing the full DFS or BFS search, marking visited cells, we can solve this more cleverly. We can scan the grid cell by cell. For every cell that contains X, we ask one question. Is this cell a start of the new battleship, or is it just a continuation of already counted one? A cell is the start of the new battleship if it is a X and there is no X directly to above it, or there is no X directly to its left. So if there is X above or left, it means the cell is part of the existing battleship, so we do not count it again. Using this logic, we can count the top left cell of each battleship. So as here we can see, this is the count and we are keeping the track of how many battleships we have found. And we are tracking the row, the number of rows in the board, and the columns, number of columns in the board. So the board is a 2D grid where X is a part of the battleship and the dot is the water. So the goal is to count the distinct battleship. So here we can see in this loop, the outer loop we are going through each row, and the inner loop we are going through the each column in that row. So together we visit every cell I and J in that board exactly once. Okay, so here we see if the current cell is a dot, that is a water, and we skip it, so we continue from here. And now we check the cell X is the battleship or not. So we are also skipping it if that is already counted in this battleship. So this is the trick. The battleships are placed either horizontally or vertically and are made of one or more consecutive axles. So we are not touching each other, no adjacent ships. So any battleships look like vertical or horizontal, but they are not adjacent to it. So to avoid counting the ship multiple times, we only want to count the first cell of each ship, the top left cell of that ship. Okay, so we are checking the above and we are checking the left, making sure they are not vertically or horizontally touching or adjacent to it. So now we are counting this battleship. If we reach count plus plus, it means the current cell is X. There is no X above it and there is no X its left. So X must be the first cell of the new battleship. So it's top left end. We increment the count, and after the loop finishes, count holds the number of the distinct battleship. So let's run the solution and submit it. We see the solution is accepted and we can count the time and space complexity. So we scan the each cell once. So it's big O of row multiplied by column, big O of row and column, and the space complexity becomes O of n because no extra data structure, no extra spaces have been taken.